All right, question number 4, we want to determine the vertical asymptotes of the graph of the function. We're going to write the numbers as a simplified fraction or integers, and we're going to give the exact form. So vertical asymptotes, we're going to focus on the denominator, and we're going to factor the denominator. So we have x plus 2 in the numerator. Asymptotes are going to come from denominator values. So we have 5x squared minus 26x plus 5. And we're going to factor this. So I can't factor out of 5. I'm going to do 5 times 5, which is going to give me 25. Factors of 25 are 1 and 25, and 5 times 5. We want to add to get 26. Okay. So I'm now going to do 2 sets of parentheses. I'm going to split up the 5x. Now this is incorrect to put a 5 in both, but it takes away the guess game and we'll fix it later. The 1 and the 25, I'm going to put those in the back. And I want these two numbers to add up to be a negative 26, which means they both need to be negative. Alright, so this is the factor form, but again, not supposed to be 2 5s, so we're going to just divide and get rid of that factor. Cannot divide 5 and 1, so I will just bring this down. Over here we can divide 5 and 25 by 5, so we'll divide and get rid of that 5, and this will be x minus 5. And once you get here, you can distribute and work backwards and verify that this, when you FOIL it out, is equal to this. So here's our denominator factor. We're going to set this equal to 0 or say not equal to 0 to find out what numbers we can't use that will give us a vertical asymptote. Setting this equal to 0, we would add 1 divided by 5, so we get 1/5 as an asymptote. So x cannot be equal to 1/5, but 1/5 gives us an asymptote. Over here, x minus 5 equals 0, and we would add 5 and get x equals 5. Now, I'm also kind of looking at the numerator, because if the factor in the numerator will divide out with something in the denominator, it is no longer an asymptote. It will be a hole in the graph, and there's still a value we can't use, but in this case, nothing divides out, and we just get these two values as our vertical asymptotes. So first, when we factor it, we already got parentheses. We need 5x minus 1, and we need x minus 5. All right, the numerator and denominator share no common factors other than 1. The zeros of the denominator are, and that was 1/5 and 5. And then therefore the asymptotes are x equals 1/5 and 5. Okay. So this is the part that was describing if it divides out in the numerator and denominator, it will become a whole and no longer be an asymptote. We're going to determine vertical asymptotes of this function as well. So we are given k of t is equal to 3 divided by t squared plus 4. Can't factor this. This is not a difference of squares. It's a sum. So I'm just going to set the denominator equal to 0 and solve it. So that's going to give me t squared equals, subtract 4, negative 4. And we have to take the square root. Well, when we get here, we get t equals, this will be I. It's imaginary, not real. Square root of 4 is 2. So this will be a 2i, if I want to write it in that order. 2i is imaginary, positive or negative, that is, because we got to do plus or minus. Imaginary is not a real number, so that means there's no number that we will plug in on the bottom and give us an asymptote. So there are no asymptotes for this problem. So it says separate answers with a comma, select none if applicable. So there are none because it's not real.